Thanks so much for having me. This here is a satellite image of central Nepal taken on April 25th of last year. Now, 35 minutes after this image was taken, a devastating 8.0 magnitude earthquake struck the country. To make matters worse, Nepal remained cloudy for many days, which made it impossible for us to use satellite imagery to assess the damage. Underneath the clouds, however, my team and I were able to use flying robots or drones to assess the disaster damage to support local recovery efforts with our friends at Kathmandu University. Now, we didn't fly these robots manually. That would really defeat the purpose of having robots. We programmed all 10 of our flying robots to operate autonomously, and it's actually quite simple. You simply drag this green rectangle over the area that you want to map, basically press go. It takes off, flies, lands, all automatically. All you really need to do then is take the resulting imagery, upload it to your laptop, and then basically process and stitch all the imagery together to create this very high resolution map of the disaster damage. By high resolution, we really mean high resolution. If you compare this aerial image with the satellite imagery that eventually became accessible and available to our partners on the ground, you'll see that this imagery is not only well out of focus, but unfortunately, because many of the aftershocks, it became quickly out of date as well. Another advantage of using flying robots is that you can create these very high definition 3D models to assess the disaster damage and to then import these models directly into a virtual reality environment so that you can assess the damage from all conceivable angles. But back in Nepal, we decided to unlock this digital data and make it more accessible by printing all of our maps on these large banners that we brought right back to the local community so they could see for themselves what the result of all this flying was about. And we even invited the community to hack the map, to annotate the map with their own local knowledge. And this generated hours worth of discussions and debates on priorities and strategies for the recovery and rebuilding efforts. And because we did this out in the open with large maps, it meant that anyone in the community could actually participate, contribute to discussions, contribute to the mapping. So it was very participatory. We did have a small hiccup, however. We completely missed one of the most severely affected areas right here in our aerial surveys. But because we had taken the time to train our local partners, and because we transferred the technology directly to them, they were able to go right back the week after and get the job done entirely on their own. And that is exactly what it's all about for me, helping people help themselves with appropriate robotics solutions. And not just flying robots, but also swimming robots that are being used right now in Nepal as well, specifically in the glacial lakes of the Himalaya. You see, climate change is having a really big effect on the Himalayas. The melting glaciers are creating hundreds of glacial lakes exactly like these ones. And these lakes are actually acting collectively as cancers, eating these glaciers from the inside out and making some of them melt almost twice as fast. And so the villages that live around these lakes are becoming increasingly vulnerable to really dangerous flash floods when these glacial lakes crack open. In fact, the local villages refer to these floods as Himalayan tsunamis. They're really, really no joke. So my colleague Juliana and her team of Sherpas are racing to better understand how these lakes form, how they grow, and how they're all connected to each other to provide early warnings of future mountain tsunamis. And the way they're doing this is with the swimming robot, basically mapping the floors of these glacial lakes, looking for cracks that may trigger the next tsunami. And just like the flying robots, these robots are also programmed to operate autonomously, giving you really high quality data in real time, as Yuli shows here with the sonar imagery.
So we are looking at the sonar, the depth, the side scan. Pretty cool, yeah, guys?
So Yuli and I are going back to Nepal next year with a number of these diving robots because we really want to get to the bottom of these glacial lakes to identify those cracks before they're even visible on the surface. And in fact, our big plan for next year is to bring these diving robots as well as the swimming robots and the flying robots to the Himalaya, train our local partners on how to use these robotic solutions to take the pulse of the Himalaya so that they are the ones who provide the warnings to the local villages of future mountain tsunamis. Now, all these activities and efforts are connected to our robotics lab in Nepal. We call our labs flying labs, and the purpose of our flying labs is to accelerate the transfer of professional and technical skills to outstanding local partners and to make appropriate robotic solutions accessible to them as well. And key to our flying labs is really the incubation of local robotics companies. We want to create jobs. We want our teams, our partners to be able to make money off the use of these robotic solutions. That's the only way that it's going to be sustainable. And all our labs are run by locals. So this is Uttam, who heads our flying labs in Nepal. He is by far one of the most dedicated, hardworking colleagues I have. I will literally get WhatsApp messages from him at 3 o'clock in the morning Nepal time when he's had another brilliant idea of how to use the robotics for wildlife monitoring or something else. It's just absolutely amazing, and it makes me inspired to work harder every day. And back in Africa, we just got back from Tanzania, where we mapped Zanzibar's largest forest, as well as some coastline areas, with the awesome team at the State University of Zanzibar, which is where we met Yusuf, who now runs our flying labs in Tanzania. He's really got a knack for applied robotics. He's a GIS pro, and equally importantly, he's really good at local community engagement, which is absolutely essential for all the work that we do. And also from the local university, Khadija here on the left and Khairat on the right, equally passionate. Khairat here is in the mobile air traffic control tower, queuing up 3 robots for landing. And her and Khadija together are really starting to inspire more women in Tanzania to take an interest in humanitarian robotics. So we're really thrilled that they're joining our flying labs as well. Lastly, we're headed to Peru in a few weeks to set up our flying labs there to recruit a local coordinator. The labs will focus here to begin with on cargo delivery of essential medicines and vaccines. We'll be working in the Amazon rainforest, where indigenous communities do not have very easy access to public health services and supplies and so on. In fact, the only mode of transportation here is a riverboat along these very, very slow-moving rivers that just wind in and snake into the Amazon rainforest. So in some areas, it'll take a riverboat about 5 hours to get from point A to point B, 2 different villages. If we use a flying robot, we can do that in 15 minutes, 15, compared to 5 hours. So we'll be field testing this particular flying robot, which was just used in Madagascar. And at the request of the Peruvian Ministry of Health, we'll be using antivenom. We'll be delivering antivenom as the first cargo. And like all of our other flying labs, we'll help incubate a local Peruvian company that will offer this as robotics, cargo robotics as a service. So to wrap up, I was going to conclude with a bigger picture and use grandiose language like democratizing the 4th industrial revolution and whatnot. But I'd rather be a lot more grounded. If you take anything away from my talk this morning, I would far prefer that you remember Uttam, that you remember Yusuf, Khadija, and Khairat. They are the ones who are working 12-hour days to make a meaningful difference in their countries. Robotics is simply a means to an end. A more efficient and more scalable means to making a difference, but it always starts with passionate, hardworking individuals. Thank you very much.